Today we're going to work on three gas laws: Dalton's law of partial pressure, the combined gas law, and Graham's law of diffusion or effusion. Make sure you have the Dalton's law of partial pressure worksheet, a calculator, and a periodic table. We'll start with Dalton's law. This law says that when we have several gases together in the same container, when we add up all their partial pressures, then that is the total pressure inside the container. A partial pressure just means that it's the pressure of a particular gas in a mixture of gases. The equation is pretty simple. The total gas is a sum of all the individual gases. You have to have at least two gases mixed together to use this law, but you could have as many as you wanted. So for example, if I have three gases in the blue circles, and we'll say the volume is 1 liter each, and the first gas might have a pressure of 3 atmospheres, and the middle one maybe 1 atmosphere, and the last one 2 atmospheres. If I were to put all three gases into the red circle together, which was also 1 liter, then the pressure of the red circle would just be the sum of the blue circles, which would be 6 atmospheres. Dalton's law is really that easy. So, this first question is right from your worksheet. What is the total pressure of a mixture of gases if the partial pressure of oxygen is 23 kilopascals and the partial pressure of nitrogen is 65 kilopascals? When you see a P with a little subscript of a chemical formula, that just means the pressure or partial pressure of that particular element or compound. And just recall from Unit 2 that kPa, kilopascals, is one of our pressure units that we have to know. So since it's asking me for the total pressure, I'm just going to add up the oxygen and nitrogen's pressure together. So the total pressure is equal to the oxygen's partial pressure plus the nitrogen's partial pressure. So it's 23 kPa plus 65 kPa. And that gives me 88. Since I'm adding or subtracting with these problems in Dalton's law, we're not going to worry about sig figs. In addition, the units have to be the same when we're adding, and they're going to be. They will not try to trick you and have you add up kPa or ATM. They'll all be kPas or mmHgs or whatever you're using. Try question 2 by yourself. So pause the video and try answering question 2 and see if you can get the right answer. In question 2, it's again asking you for the total pressure. So we're going to add up the oxygen, the nitrogen, and the helium. So that's going to be 25 plus 18.7 plus 34.6. Of course, they're all in kilopascals. Well, that's fine. And when you add those up, you get 78.3 kilopascals. Again, we're not going to worry about sig figs when we're adding, so don't worry about sig figs. Go ahead and pause your video and complete the Dalton's law portion. Then when you've tried all the rest of these, which would be numbers 3 through 9, go ahead and play the video again and check your answers. Again, don't worry about significant figures, but you should have units in your answers. Be sure you show your work on your worksheet. Don't just write down answers. The next gas law is a combined gas law. It's called the combined gas law because we're really looking at Boyle's law and Charles' law together to make the combined gas law. So there's Boyle's law, and here's Charles' law. The combined gas law is a combination of these two. So we're just having PV over T equals PV over T. And this gas law is also located on your worksheet at the bottom of the Dalton's law. The temperature will have to be in Kelvin, just like the other gas laws. To get Kelvin, you're going to add degrees Celsius plus 273. So in the first question in your worksheet, we have a gas at 135 degrees Celsius exerting a pressure of 215 kilopascals when its volume is 0.395 decimeters cubed. If the temperature is raised to 245 degrees Celsius, at what volume will the gas exert a pressure of 187 kilopascals? So the first thing you want to do is label the different parts of your equation. So 135, I'm going to call that T1. A gas exerts a pressure of 215 kPa. That's associated with the 135, so that's P1. When its volume is 0.395 decimeters cubed, that's V1. If the temperature is raised to 245, so here's T2, at what volume will the gas exert a pressure of 187 kPa? So I'm looking for a volume, and it gives me P2. So P1 is 215 kPa. V1 is 0.395 decimeters cubed. T1, I need to add 273 to my 135, and that's going to be a 408 Kelvin. So 408 down here came from 135 plus 273. Then equals the new pressure of 187 kPa, my V2, which is unknown, and my new temperature of 245 degrees Celsius, which again I need to add 273 to, which gives me 518. All right, pause the video right now and try to make sure that you remember how to cross multiply. Then I'll show you how to do it if you're having trouble. So once you have the setup for a combined gas law problem, you're going to multiply the diagonal that does not have the unknown, that has all numbers. So you're going to multiply those three numbers together, and then you're going to divide by the other diagonal that has the variable. So on your calculator, you will type in 215 times 0.395 times 518, divide by 408, divide by 187. Your answer should be 0.577. And then in terms of units, you're going to cross out kPa, cross out Kelvin, so the unit left over is dm3, which is our volume, which is what they asked me to find, so that makes sense. Let's look at question 2. Pause the video and label the pressures and volumes and temperatures for the numbers and unknown in question 2. You should have picked out 265 as being T1, 2 milliliters being V1, and 120 kPa as being P1. It's asking for a new temperature, so that's T2. The new volume is 3 milliliters, and the new pressure is 100 kPa. So to set this up, it will be 120 kPa times 2 milliliters over 265. Since it's already in Kelvin, I don't need to make any changes. Equals 100 kPa times 3 milliliters over unknown temperature. Go ahead and cross multiply your equation and see if you can solve for T2. Go ahead and pause the video and try that. You should have gotten 331. In terms of units, the kPa's are going to cross out and the milliliters are going to cross out, so I'm left with Kelvin. I'm going to look at sig figs. I'm going to have only one sig fig in the 100, so that's going to be 300 Kelvin. Now, if you had trouble with the actual calculation and could not get 331 on your calculator, that's not a chemistry issue, that's a math issue. So I'm going to review that real quick. We're going to cross multiply. I'm going to multiply the numbers that don't have an unknown. So I'm multiplying what I have in red. And then I'm going to divide by the numbers that are in green. So on the calculator, it would be 265 times 100 times 3, divide by 120, divide by 2. Now pause the video and try the remaining questions on the combined gas law on your own. Make sure you show your work, units, and significant figures. One of the key strategies is to just label each number inside the word equation in order to plug it into the combined gas law. You have to also remember to change your Celsius to Kelvin. So go ahead and pause the video. When you're done, play the video again to check your key. The last gas law we're going to talk about this unit is Graham's law of diffusion, or Graham's law of effusion. Diffusion is just moving of one gas through another. So if you stand in the classroom and spray perfume, the particles of perfume will diffuse with the rest of the air in the classroom. And this is a natural process. It's going to spontaneously spread out through the whole room and mix. Effusion is when gas escapes from a tiny opening. Like if you have a flat tire, or even in balloons. They all have a little tiny openings where gas molecules are able to escape over time. The speed or rate of this diffusion or effusion process depends on the mass of the particles involved. The lighter the molar mass of a gas particle, the faster it moves. Here's where you're going to need your periodic table. So based on molar mass, which of those gases in each pair will move faster? Go ahead and make your choices and check your answers on the next slide. So hit pause, choose an answer for each of the 4 questions, and then replay the video. The answers are based on the lighter molar mass. And the next part is a demonstration that you're going to watch. Find the picture of the tube with NH3 and HCl on the back of your worksheet under the combined gas law problems. Based on the notes that we just looked at, predict which gas will diffuse faster, the hydrochloric acid HCl or ammonia NH3. And sketch a line on your worksheet predicting where the gases might meet. For example, if you feel like they move at the same speed, you would draw your line in the middle between the NH3 and HCl. If you think NH3 moves more slowly than HCl, you would draw your line closer to NH3. And if you think HCl moves more slowly, you draw your line closer to HCl. So pause and make your prediction, and then resume the video. Now you're going to go to the link listed below and watch a YouTube video with this demonstration. Record what you see under number 2 under the Graham's Law of Demonstration worksheet. Lastly, just answer questions 4 through 8 based on the notes and video that you saw, and turn this worksheet in with your purple log with the sub today.